right, so this is 13.2 notes of our trig unit, day 2 of 3 for our trig unit here. So make sure you've got out your packet of notes ready to take notes with me. An angle is in standard position when its vertex is at the origin and one ray is on the positive x-axis. The initial side of the angle is the ray on the x-axis, and the other side, or the other ray, is called the terminal side. An angle of rotation formed by rotating the terminal side is formed by rotating the terminal side and keeping the initial side in place. So on this first example, our initial side is on the x-axis, and then the terminal side, and then you would rotate. Going counterclockwise would be a positive rotation. So going counterclockwise would give us an angle of positive 135 degrees. So again, the initial side is on the x-axis and the terminal side is the other. For negative rotation, again, the initial side is on the x-axis, but instead we're going to rotate clockwise. So this would be a negative 45. The other measurements that are here are on the x and the y-axis. So you'll notice as we go around, we get to 90 degrees, and then 180, then 270. That's for positive rotation. But if you're going the other way, the first time you get a quarter of the way around, that's negative 90, then negative 180, then negative 270, and then back to negative 360 or 0. Coterminal angles are angles in standard position with the same terminal side. The reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. So on this left side here, we've got information about coterminal angles. So you can see our initial side right here on the x-axis and our terminal side over here. If we were to go in the positive rotation, then that would be 120 degrees. But if we went with the negative rotation going clockwise, we're going all the way around 240 degrees. So 120 and negative 240 degrees, depending on which way you're going, will give you the same initial side and terminal side. It just depends on which way you rotate it to get there. So 120 and negative 240 are coterminal angles. For the reference angle, again, our initial side is on the x-axis and our terminal side is over here. If we were to rotate positively, so going this way, that would be theta, but we could use a reference angle as this one right here. And so that would just be the acute angle formed by the terminal side and the x-axis. So the orange one is not acute, so we cannot use that one. That's the obtuse angle. But an acute angle, less than 90 degrees, is formed between the terminal side and the x-axis, so that is our reference angle. To determine the value of the trigonometric functions for an angle theta in standard position, you begin by selecting a point P with coordinates xy on the terminal side of the angle. So you can see P of xy, or point P, which has the coordinates xy, right here on the terminal side of our angle. The distance r from the origin to that point is given by the square root of x squared plus y squared, which if you replace that with a and b and made it equal to c, that would be the same thing as your Pythagorean theorem. Okay, so then if we're looking at this, let's go ahead and highlight a little bit. Okay, so the distance from the point to the origin is r, and x and y, they can be positive or negative, but if we want to make a triangle out of this point and the x-axis, then the y value would be positive for this specific one, but we would still just use the absolute value of y. And then if we wanted to look at the x, this specific point would have a negative x value, but the length of this side is going to be the absolute value of x. And then we've got these two pieces of information here. We've got theta and we've got theta prime, and then we've got theta over here. So with the little apostrophe is theta prime. That's just a mess of colors all over that. But so if we have sine of theta, so each of these is about our theta. Okay, so the sine of theta in green would be the value of y divided by r. Cosine would be x over r, and tangent would be y over x. And because we know if we've got going all the way across, that's 180 degrees. So if you wanted to figure out how these two are related to each other, if you take 180 minus theta prime, that will give you theta. Or if you knew the other one, that would be 180 minus theta. Because all the way across from the x-axis to the x-axis again would be 180. So then if we are looking at these other equations over here, maybe these are a little bit easier to wrap your head around because it made a triangle. So if we have the sine of theta is opposite over the hypotenuse, so that would be the absolute value of y over r. Cosine is adjacent over hypotenuse, so that would be the absolute value of x over r. And then tangent of theta is opposite over adjacent, so the absolute value of y over the absolute value of x. So if you're comparing the two sets of these things, if you're looking, okay, well, tangent of theta looks really similar to the tangent of theta prime, right? We've got y over x, but for theta prime, it's the absolute value of y over x. So that's really the only difference here. Same thing with the cosine and with the sine. And then cosecant, secant, and cotangent, remember those are each just the reciprocal of sine, cosine, and tangent. All right, so then we have the must-know chart, and we've already referenced it before, and you need to make sure that you know this chart. You must know it. And we've got it in degrees and radians for this chart. And we've got cosine, sine, and tangent. So the cosine is always going to be your x, sine will be y, and tangent will be y over x. And you'll get more acquainted with this chart as we go, but make sure you know it. All right, I will see you in class if you have any further questions, and we'll be doing a couple of examples together. Hope you're having a great day. Bye.